Hello, everyone, and welcome to our latest DZone webinar. My name is Jason Cockrum, and I'm the Community Engagement Manager here at DZone. And we're excited that you're here. We've got a great topic today. It's exciting and it's relevant for us as developers, so we're glad that you've joined us. If you're new to DZone, we are one of the world's largest online communities of software developers and experts, and we publish all sorts of knowledge resources for developers and really anyone passionate about software development. We've got all kinds of stuff from ref cards and trend reports to thousands of articles written and published by members of our community. So this all makes us kind of the go-to knowledge hub for senior developers, for software developers all over the world. Joining me today, I have Julius Volz and Scott Kelly. Julius co-founded the Prometheus monitoring system and originally led the project to success at SoundCloud and beyond. And he now focuses on growing the Prometheus community and helping companies use and adapt Prometheus through his company Prom Labs. And before creating Prometheus at SoundCloud, Julius spent some time as a site reliability engineer at a little-known company named Google. So welcome, Julius. Thanks for being here. And then Scott Kelly is a senior product marketing manager at Chronosphere. Previously, he was in product marketing at VMware, where he worked on the Tanzu observability or Wavefront team. And he partnered go-to-market efforts for that team with AWS and Microsoft Azure. So a lot of experience on the cloud, all the kind of cloud stuff. And then before VMware, Scott spent 3 years with Dynatrace. So definitely quite a bit of knowledge he brings to the team here today. Prometheus, if you're not familiar with it, it's a powerful metrics-based monitoring system specifically for the cloud-native world. So all those cloud-native systems and applications and things that you might be needing to run specifically in the cloud, Prometheus helps provide monitoring for that. Today, Julius is going to walk us through a demo of how Prometheus works and some of the most important reasons why it has become the de facto standard for monitoring in cloud-native environments. And then Scott is going to show us how Chronosphere's cloud-native observability platform helps us quickly implement Prometheus into our environment. After the presentation, I'm going to jump back in and answer a few questions. We're all about community here at DZone, so we encourage you to get involved and to get engaged in our conversation today. On the right side of your screen, you'll see there's a box where you can chat with other attendees about what's being discussed today, and you can even submit questions to our presenters, and we'll do our best to cover as many of them as we can at the end. At this point, I'm going to hand it off to Julius. So Julius, take it away.
Thank you for the lovely introduction, and I'm super happy to be here today. Thank you to Chronosphere and to DZone for having me. And so again, I'm Julius. I'm both the co-founder of the Prometheus open source monitoring project, but also the sole person behind the company Prom Labs. So with Prom Labs, I mostly do trainings these days, both live trainings around Prometheus and self-paced online courses at training.promlabs.com. And today I'm going to do something a bit unusual for me, which is a bit more marketing-ish, which is to talk about the 5 reasons why you might want to go with Prometheus when you're looking at cloud-native monitoring. So first, if you have not heard about Prometheus yet, let's talk about what it actually is. So Prometheus is a metrics-based monitoring and alerting stack that works particularly well with dynamic cloud-based environment. And it's also open source. And the history behind Prometheus is that we started it 10 years ago. So we were coming from Google to SoundCloud, and we kind of missed Google's internal Borgmon monitoring system, and we already found a very dynamic cluster-based environment at SoundCloud and didn't have anything proper to monitor it. So that's how the project originally got started. And then after some adoption at SoundCloud, we fully published it in 2015. And then in May of 2016, we joined the Cloud Native Computing Foundation as the second project in that foundation. So guess what the first project was? That was Kubernetes. So Kubernetes was basically the project for which the CNCF got created, and we were the second one in there, fitting thematically really well. And by now, there's just many, many projects in there. Just a couple of months later, we then released the first stable major version of Prometheus 1.0. And then, of course, it was still pretty early, so we still wanted to do a lot of breaking changes. So not too much later, we released Prometheus 2.0. But since then, since 2017, we have actually been able to not break any major API services in Prometheus. So by now, we're still on version 2.x without breaking much. And we're still able to improve the stability, add features, integrate with more and more things. We have Prometheus conferences. We have started to standardize some of the interfaces in Prometheus. So, there's a lot of maturing going on. Just as a quick architecture overview, typically you would run Prometheus as one or multiple servers in your infrastructure. So that's the middle box here, where you configure that Prometheus server to collect metrics over HTTP from a set of things that you want to monitor. We call these targets. And those could be services where you control the code and you can directly use a Prometheus instrumentation client library to expose the most beautiful metrics from directly inside of your code. Or it could also be some third-party code bases or even hardware devices where you cannot directly do that. So for that, the model of running a little agent next to the thing you care about, we call that an exporter. And that does this translation into this text-based Prometheus metrics format for you so that Prometheus can scrape metrics from that device or third-party software. Now, then Prometheus collects and stores those metrics on a regular basis. And it builds time series out of them over time. And then in the end, it allows you to both query and visualize and generate alerts and do all kinds of other useful stuff based on the data you collected. And one important thing here is for the cloud native world that Prometheus integrates very well with all kinds of different types of service discoveries in your environment. So, for example, it can talk to a Kubernetes API server or to DNS or Consul or other sources of truth to continuously, on an ongoing basis, discover these targets on the left to know all the things that it currently should be monitoring. Okay. So let's go into the first reason why you might want to use Prometheus, which is that by now Prometheus is very mature and the ecosystem is also mature and large. So, we started it 10 years ago and it's open source or really fully public since 8 years. We are at a pretty stable version 2.x for a long time already. And for a long time already, you've been seeing startups and big enterprises and banks using Prometheus for their mission critical monitoring. So you have Walmart and Disney and all kinds of other big players using it. Also, since we have a huge community, there's just many people helping us integrate with anything under the sun. So we have almost 1,000 exporters only that we know about, but there's probably way more. So these are all these little agents that help you get metrics out of the different things that you care about. And there's also a lot of software out there in these days that directly exposes Prometheus metrics about itself. So you don't even need an exporter anymore. And also you will usually find for any language, any major language, a client library that allows you to put metrics out from your own code. Second reason, let's talk about Prometheus being the de facto standard in open source metrics-based monitoring and what that means also for portability. So GitHub stars is a little bit of a vanity metric, but as an open source project, we don't have really great, metrics about how many real users are there, how many installs are there, because we don't send home telemetry. So this is a kind of fun proxy metric, at least, that shows some level of popularity of the project. But by now, I think it's really fair to say that Prometheus has become the de facto standard for open source metrics-based monitoring. And if you just compare this to Kubernetes, Kubernetes is one of the largest open source projects in the world. We have almost half of the number of stars of that, just to give you kind of a sense of scale. And by now, almost everyone, for that reason, wants to integrate in one way or another with Prometheus. So on one hand, you have the large cloud vendors in here, AWS, Google Cloud, Azure, who basically have managed Prometheus offerings where you can send Prometheus data and they do Prometheus compatible querying for you, or at least they will claim that they will do that, and some also do. And you also have Chronosphere on here, by the way, who is co-hosting the session here today. And they also give you a service where you can send your Prometheus data and then have alerting and dashboarding and everything based on your Prometheus data so that you don't have to run it yourself. So all these kinds of integrations are happening And, in the past, there's a question here, how are these different players integrating? In the past, when we started out with Prometheus, there was a lot of focus on the actual boxes of specific implementations from the open source project. So you had in the middle the Prometheus server. It's pulling some data from a target. It's potentially forwarding them to some remote storage system. Maybe it's being queried or it's sending out alerts. But nowadays, since everyone wants to interoperate, the focus is much more on these arrows in between the boxes. So this layout here, where we're working on standardizing and re-implementing in different implementations with different trade-offs, the different arrows here, right? Like, how does a Prometheus server get metrics out of a service or a target? That's the exposition format. We have the remote write protocol. That is how Prometheus can forward already collected data to some potentially more scalable or durable storage backend. And the PromQL query language is a very major interface that is basically the big interface to do anything useful with the collected data. And then also the alerting protocol. So, many different players here. These are ones that are actually relatively PromQL specific, that allow you to query back the data that you send to them in a PromQL almost compatible or fully compatible way. And this is really great in general. So, if we have all these open standards for these interfaces, then that allows users to choose between different trade-offs. So you don't necessarily have to go with just the vanilla open source upstream implementations. You might go with some cloud-based solution or a different open source based one that is maybe more horizontally scalable and so on. And this in general leads to a larger ecosystem with better competition, which is hopefully better for everyone. But of course, there's one big caveat, which is compatibility, right? Once everyone starts implementing similar interfaces, you hope that they're not just similar, but actually compatible. And, to kind of try to ensure that more and more, as the Prometheus open source project, we are starting this Prometheus conformance program with both a technical part and a legal part. And both are still a work in progress, but progressing fast. We have the technical part is a repo where vendors can self-certify that they are compatible with certain interfaces. And then the legal part is basically still being defined together with the Linux Foundation, where a cloud vendor who claims to be Prometheus compatible can create a contract with the Linux Foundation, and then after self-certifying, they're able to use certain compatibility marks in their copy. Reason number 3, open source and open governance. So Prometheus is open source, which of course, first of all, means it is free to start using. Of course, it's not free to use. You have to invest time and engineering effort and everything, but you don't have to pay license fees. It's not a black box, which means A, you can look inside, but B, you can also modify it to your needs if you need to. And there's not one single company behind it. So, it survives single companies going bankrupt or going out of business for some other reason. Besides that, us being part of the CNCF means that we have a neutral home. The CNCF owns the official assets like the domain, the trademark, and some other stuff. And it helps us in different ways with events and lots of support. But it also means that it's kind of a Switzerland where all kinds of different companies and stakeholders can come together and they can all work on Prometheus together under an open governance. So we have the governance actually defined under the link on the slide here. And it just means, you can actually also come in and you can start contributing. Maybe you will become a team member after a while. Then you can start voting on the project direction. So you can have an actual voice as well. And finally, there's the open source and talent pool aspect. Engineers really love working on open source software. So that also means that you can find a lot of people who would love working on open source Prometheus, but also generally because it is already the de facto standard in that area, you will already find a lot of people as well who can do that. So that should help as well. Reason number 4, I think this is like one of the biggest technical selling points of Prometheus, is the query language that we have, PromQL. Basically, it's a read-only functional query language that is specifically built for doing cool stuff with metrics. So selecting metrics and then transforming them and aggregating them, but also doing all kinds of vector arithmetic math between sets of metrics. And the idea here is really that you collect all the data as metrics, as kind of in this label-based dimensional format in Prometheus first. And then there's this one unified query language that allows you to cover all kinds of different use cases. So not only alerting, but also dashboarding in one system with the same language, and ad hoc debugging as well, or capacity planning, or automation, or data science, or any other kind of things you can think of that fit into this metrics-based model, usually go through PromQL as a layer. And here is just a small example PromQL expression. So it's like a functional nested language. So you have stuff like metric selectors, then you have functions that allow you to transform things. In this case, we're taking the per second rate of an increasing counter. Then maybe, these are many, many individual rates. So we're aggregating over certain dimensions to have fewer time series as an output. Then we have an arithmetic binary operator taking the upper side and the lower side of this whole expression here and dividing them by each other on identical label sets in the kind of automatic join situation that I won't go into. But that's kind of powerful, where you really are able to do math between entire sets of numbers that are correlated with their label sets. And then as an output, again, you get another whole set of numbers that is correctly labeled. Filtering binary operators. So there's many more features. There's histogram stuff, quantile stuff, and so on in PromQL as well. But this was just a small example. And yeah, since PromQL is sometimes a bit complex, or it is a deeply nested language, and you're sometimes not sure what kind of data you're working with at some deeply nested node, I started building this PromLens query builder and explorer tool 2 years ago. First as a commercial tool, but then Chronosphere integrated it into their platform, and then also helped us together. Basically, we open sourced it last year. So now it's part of the open source Prometheus project under Prometheus/PromLens. And yes, just if you're doing PromQL, I can just recommend using it to get insight into what's happening in your queries. For every sub-expression here, you see what data you have. You can click on those subnodes, see the graphs, see the tables, and so on. So it's quite helpful with that. And for the last reason here, Prometheus actually works out of the box really well with Kubernetes. And that is no accident, because in Google, there was Borg and Borgmon. Borg was the cluster manager system where everything in Google ran on. And then Borgmon was the monitoring system to go along with that. So basically, both Borg, the cluster itself, was monitored with Borgmon, and everything running on Borg was also monitored with Borgmon. So that's Gmail and search and all these services. But then both of these internal implementations got open source implementations, or ones that were at least inspired by the internal Pondo. So Borg inspired Kubernetes. That was directly done by Google itself. And at a roughly similar time, but without any coordination, we at SoundCloud created Prometheus, inspired by Borgmon. So there's a good reason why these systems interact pretty nicely with each other. And when we fully published Prometheus, that was also kind of the time when Kubernetes started to become big. And they pretty quickly added support for Prometheus as well. So you have, on one hand, support in Kubernetes for Prometheus. So you have all these different cluster components and the servers that are part of Kubernetes serving native Prometheus metrics endpoint. And that is the primary format in which Kubernetes exposes Prometheus metrics. So you have the Kubernetes API server. You have the kubelet on each host that runs and manages the containers. both exposing Prometheus metrics, you have etcd exposing Prometheus metrics, and other cluster components as well. So really easy with Prometheus to monitor the cluster itself. And then in the other direction, Prometheus also supports monitoring stuff on Kubernetes really easily. So that happens because Prometheus is able to talk to the Kubernetes API server in an ongoing continuous way for service discovery to discover your service endpoints or pods or ingresses and all kinds of other cluster objects to not only find out that they exist, but also what they are. So you get a lot of rich metadata labels that can then be inherited into the pool time series of those services and pods and so on. So basically, monitoring works pretty much out of the box in both ways in a Kubernetes and Prometheus scenario, and in almost every almost every Kubernetes cluster, you will also find some kind of Prometheus stuff somewhere. And yeah, I think it's really the best way to do the metrics-based monitoring in Kubernetes cluster, because you don't need any additional translation layer that maybe even uses a slightly different data model, so you don't get as clean as metrics as you would in the original form. So in a Kubernetes scenario, it's really nice to use Prometheus. All right, just to summarize those 5 points. First, we have the large and mature ecosystem, which helps you really have some trust in Prometheus. Then we have the portability and standard aspect. And we have the open source aspect that allows you to both, inspect and change and also have some influence in the system if you want to. And the query language really is just a technical enabler for all kinds of different use cases, from alerting to dashboarding. And with Kubernetes, it just works very well out of the box. All right, so I have some resources for you to get started as well. On one hand, there is the official open source project website, Prometheus.io. It has kind of the full documentation of all features that exist, but it's maybe not always the best place to fully learn everything from scratch in a structured way, because it's more of a reference and not a kind of training. So, as part of what I'm doing, I'm creating these self-paced training courses as well, training.promlabs.com. And, while they are paid, some of them are free as well. Hopefully they're helpful. And by the way, if you are a Chronosphere customer, you actually get these for free. There's a separate URL for Chronosphere users where you can just go to and get all the content for free. Okay, I'm going to do a short demo, or actually two. So the first part is just showing how easy it is to kind of download Prometheus and monitor the local host metrics. And then the second part, I'm just going to show Prometheus already running in a single node Kubernetes environment, so a little bit more complex, and just to show you like the kind of metrics you can automatically and easily get there. All right, so to download Prometheus and kind of get host metrics, we're going to first download the Prometheus server itself. So I'm going to click on this. And I'm also going to go for the node exporter, which allows me to, this is kind of this exporter that, fetches metrics about the current system that it is running on, in this case, my local Linux system. And I'm going to just unpack both of them. And let me actually start the node exporter first. Oops. Here it is. So the node exporter is, it has a lot of flags that we could set, but by default, if we don't set any flags, it will start up. Once I start the one that's running, stop the one that's running on the system, it will start up like this, listening on port 9100. And if I go there to that port, you will see the Prometheus metrics endpoint of that node exporter. So that's the default /metrics endpoint that delivers this text-based format. The only reason why it looks colorful in my browser is because I have a specific plugin for that. Usually it's just plain text. And you can see a lot of metrics on here about the node that it is running on. So we have some kind of cooling metrics and CPU metrics, and we'll also find some memory metrics and file system and everything. So basically what we want is to run a Prometheus server to go to this endpoint on a regular basis and store the current state of all of these metrics. So every time I call this page, it just shows me the current state of all the metrics in this system or on the host. So what I'm going to do is I'm going to go to the Prometheus configuration file, and I can leave the scrape interval at 15 seconds, but maybe for demo purposes, I will scrape every 5 seconds to make it a little bit faster. We don't need the eval interval. We don't need alerting right now or rules or any of that fancy stuff. And at the moment, in this config, it would only be Prometheus scraping itself, which is fine. Like Prometheus also produces Prometheus compatible metrics about its own inner workings. But we also wanted to scrape as a separate scrape configuration, as a separate job, so to say, the node exporter on localhost 9100. So right now I have basically 2 targets that this Prometheus configuration would start scraping. And by default, Prometheus will load its configuration from prometheus.yaml, and it will start storing any local time series data in just a local data directory, which is also configurable, of course, but the default is fine for us here. And so now we have Prometheus running on port 9090. And if we go to the targets page, we see that the 2 targets, both itself and the node exporter, are being scraped correctly. So they're in an up state. And I should be able to see some of the node metrics if I go to the graph page here and just start typing node. I see a lot of metrics coming in about the node that I'm pulling. So that's how easy it is to get started with Prometheus, right? You just have the static binary, you give it this one config file, and it just starts storing its data on local disk. And all you need to pull metrics data from something is kind of this text-based format being outputted, which is, you could theoretically even generate it from a bash script. And yeah, so I could run some PromQL queries here, like something about the CPU usage, like this. We don't have a lot of data yet, so this won't look too great. Yeah, it would start looking a little bit better after a while. But basically, this would be like the CPU usage in cores split up by each CPU core and the usage mode. And then it could add different kinds of aggregation in here, like removing, kind of aggregating over all the different CPUs and showing the total idle usage, the total user usage, and the total system usage, and so on. All right, that is kind of just how you could get started on your own local system really quickly without big explanations with Prometheus and the node exporter. And then I also have Prometheus running on a single node Kubernetes cluster and kind of brought it up with a whole framework where it gets started along with a Grafana dashboard builder, and a lot of default dashboards are created already for it, where you can see everything that is going on that system and on that cluster. So you can see the cluster resources, you can see cluster resources grouped by pods, different kind of metrics about the cluster itself and the workloads running on that cluster. And if you check out that specific Prometheus server, it will have quite a complicated configuration, but this is auto-generated by an operator running in the Kubernetes cluster that it just generates that Prometheus config to talk to the service discovery of the Kubernetes API server, discover all the different things, all the different target groups here, different alert managers, black box exporters, Grafana, the Kubernetes API server. Everything gets kind of discovered, and then Prometheus starts pulling metrics from all these things with these labels that you can see here, and then you end up with a whole bunch of labeled time series that you can make use of in different ways. So that's just something I wanted to show really briefly, and that's already kind of the end of my demo. I'm not going we'll go into alerting and other fancy stuff right now, although that is also pretty cool. All right, so I will just briefly show the video conferencing interface to turn off my camera so we can actually go to Scott's part, the Chronosphere part of the presentation. Scott, take it away.
Great, thank you very much. That was awesome. First of all, like at Chronosphere, we're very supportive of people getting started with Prometheus when they're moving to cloud native. It's a very great solution. It works out of the box and all the reasons that Julius just described. But next, on the next slide, when you get to a certain scale, you can start to lead to some issues. We have some great assets that we have links to at the end of this presentation that go into more depth about what those are. But there's a few signs that you might run and start to see as you scale, and we'll walk through these pretty quickly just to give you an idea. And again, like I said, there's some more assets that we can go through that describe the issues and how they're a problem and what the things you have to do and the steps in more depth. So first of all, the problem with one of the issues with cloud native environments is that they create a lot of data, like 10 to 100x times their their virtual machine counterparts. And so with that said, as the data starts to grow, these issues start to become a problem. So for example, not being able to find data quickly, having to look around, engineers having to go look for data, sifting through data, trying to find the right dashboards can really start to impede troubleshooting efforts. The other issue is with data retention. Some of the things that you have to do within Prometheus to retain data for longer times can be cumbersome, and that can cause challenges. You may see decreasing reliability, and this means that as you add more data into the system, it may be more difficult for alerts to fire on time, for dashboards to load, and that can impact your ability to keep your systems running reliably. And one of the other things is that that cost versus collections trade-off, right? So you may start to, as you grow and as you're collecting more data, it may get to a point where it's very expensive, and now you're making decisions about which data to collect, which data to keep. And when you start to have to do that, you start to potentially negatively impact your ability to remediate issues and run Prometheus effectively. On the next slide. And that's where Chronosphere really comes in and shines. So Chronosphere is a single tenant SaaS cloud native observability platform. We ingest metrics and traces via open standards and to enable rapid remediation. It's incredibly reliable, and we actually offer one of the highest SLAs in the industry. So when you see here, you can see that our collector allows you to collect metrics and trace data in your environment, and we support all standard open source formats. So for Prometheus, it supports all standard discovery and configuration options that you'd be using. And it uses a lot of the Prometheus open source code base. So it works really well. Next is our control plane. And this is incredibly unique in the market. It lets you fulfill your existing dashboard and alerting needs without having to store all of the observability data in raw form. What we do is we pre-process it and optimize the data. The result is a reduced cost and improved performance. So how do we do that? First, we analyze. We allow you to analyze and understand the value of your observability data. What's valuable? What's junk? What can you get? What do you not need? Next, we give you tools to shape and transform data based on need, context, and utility. You can control these costs by optimizing your data sets, and it gives teams the right data to solve problems faster. And then we also allow you to delegate responsibility to control cardinality and growth. So we allow you to set quotas. So teams will now be responsible for managing their own metric data. And this can control overages and things such as cardinality spikes that can cause havoc with the system. And as I said, lead to cost overruns and impede other users of the system. And lastly, we provide tools to allow you to continuously optimize the platform. So we have things like what's called a query accelerator, so that if anything changes within the platform that causes the query to slow down, we can actually help optimize it again. So everything runs fast, dashboards load fast, and alerts fire on time. And so now we have the Chronosphere data store, and we have the most efficient engine for collecting and storing your data at scale. We learned how to do industrial, high-performant, and highly available storage for building M3 at Uber. That's where our founders came from. And this database is proven to scale to 2 billion data points per second, or 20 billion active time series. So it's pretty scalable. And then next is our query engine. It's 100% PromQL compatible. And as you saw with Julius, he was showing you how the power of that. He talked about the query builder that he built and we worked on together to integrate into the product. So it's very easy to use and very powerful. And it allows you to, as I said, 100% compatible. So if you're familiar with the PromQL language, you can use our solution out of the box. All right, next slide. And so this is why many of the leading cloud native companies decide to use Chronosphere. And here's why. First of all, we help reduce observability data volumes by 50% or more. And we do that by the controlling and shaping tools that we provide within the platform and the control plane. And this helps you reduce your initial data volumes, but also control long-term growth. And then there's our 100% open source compatible. So you have no vendor lock-in, right? We talked about that. The collector is all open source compatible. The database is also open source compatible. We're PromQL, 100% open source compatible. So all the ins and outs of the platform are 100% open source compatible so that you don't have to worry about vendor lock-in. And we're one of the most reliable platforms out there. While we promise our SLA is at 3 nines of uptime, we actually have been delivering an SLA that is better and as close as 4 nines and plus on that. So very, very high reliable. And then lastly, on average, our customers spend 50% less time troubleshooting. So because of the shaping capabilities and the speed and the reliability of our platform, engineers get the information they need to quickly find and fix problems. And that's the reason that, there we see when we talk to our customers and measure, they're finding about a 50% reduction in the time they spend troubleshooting. And the next slide. And so here you can actually see some of the impact that these customers. So for Robinhood, for example, 4 times reduction in mean time to detect. For Abnormal, they had we're 10 times more cost effective than other solutions. And you can see DoorDash here, 20 million unique time series ingested and analyzed, massive. And then for Zillow, they got 300,000 active alerts in production. And so here is a list of resources that you can follow up on further. As I said, there's some information there that can dive deeper into the challenges and problems you might see as you start to scale Prometheus. And you can see a couple of case studies here as to a couple of customers who turned to us when they were having challenges and the success we've had with them. And if you want to talk, please feel free to reach out to us. I would love to give you a demo, just talk about your situation, and we're happy to help. And with that, my part's done. Thank you.
All right, cool. Thanks, Scott. And thank you, Julius, for that. So yeah, as you can see, there's some contact information there on the screen for Julius and Scott if you have more questions. We've also offered, there's 2 handouts that you should be able to access now in the chat on the box, on the box on the right side of your screen. So feel free to explore those later on your own time. We also have a couple of questions that I think we're going to run through. As we're answering these, feel free to, if anybody else has any questions, continue to add those. We still have a few minutes left, so let me click over these questions here. Okay, awesome. This first one looks like it's going to be for Julius. Okay, when getting started with Prometheus, do you recommend doing it yourself or finding a hosted version?
Oh, good question. So, I mean, of course, I'm a little bit biased when it comes to that. I'm a fan of the open source project and running things a little bit with yourself and as close to your targets as possible, right? It's your monitoring. But ultimately, there's just, different systems have different trade-offs, and hosted services might, take a lot of work away from you, which is great, but also have different features, right? They might be a more horizontally scalable and super durable system. They might have extra features that you need. So I think in the end, it's good to know and start a little bit with the open source version of Prometheus, just so you know which parts of it you are actually already outgrowing and where you need more, just to understand it better. But then it's totally fine to, once you understand it, to go with something else that is hosted or a different kind of re-implementation. I would say that's totally dependent on what you need.
Very cool. Very cool. Yeah, that's one of the biggest benefits of being open source, right? You can just kind of play around with it at first, so you figure out how you like it, figure out how you want to use it, and then you can explore further options.
Yep.
So very cool.
And I would also say, Prometheus does, it can get you very far. With even one very big, beefy Prometheus server with lots of RAM, you can track and store many millions of time series at the same time. And you can then typically, people would even run many of these Prometheus servers together, and then they start integrating them like with the Thanos system on top to get an integrated view. And at some point you might get to a point where there's just too much data, like hundreds of millions of time series, or even somewhat below that, where you're saying like, okay, I want some kind of big centralized cloud scalable layer that just does this for me. But I would still say like a local big Prometheus vanilla install can really go quite far.
Cool. Yeah, and actually, kind of follow on with that, you mentioned scaling, right? And as companies, as people are looking to scale up, what are some of the challenges that you talked a little bit about it, but could you be a little bit more specific, or maybe even provide some examples of some of the challenges we might face as we're trying to scale this?
Right. So, fundamentally, each Prometheus server in itself is not a horizontally scalable system. It stores its time series database on local disk, which could still be a network mounted database, but it's not, it's still limited by the scaling of that single node. And so what you can do with Prometheus once you outgrow a single node is you start running multiple nodes, but then there are some ways to do horizontal sharding for sure. But you often start out with kind of functional sharding. Like one team has one Prometheus server, another team has their own Prometheus server, and they're both monitoring mostly their own services. So you end up with a little bit of a silo situation where it becomes a little bit harder to do queries across multiple Prometheus servers, and to kind of, what happens if suddenly there's double the amount of service instances, and now you're, within that one functional Prometheus server, the number of time series doubles overnight, and you don't have that one button that you can just press to horizontally scale. There are ways to build that with the open source vanilla Prometheus and the kind of Thanos layer on top. That's another open source system that is very close to the Prometheus open source project in terms of developer overlap and technology and shared libraries, where you can just basically put a query layer on top of multiple Prometheus servers to make them look as one. But that, becomes already more challenging and complex to handle, right? And you need to have quite a good operational understanding of all these things. And so there, it can be nice to just have someone who really knows how to do that, to do that for you, to manage that for you, and then you also don't have all that huge amount of data locally on site, right? So that's where services like Chronosphere can really help you. And they also have this great data ingestion layer where if too many time series do come in, because you're kind of splitting them up by too many different dimensions, each layer, you can see that, you can detect it, and then you can also create rules in there to aggregate the data so that there's actually less data to store.
Very cool. Yeah, Scott, he just mentioned, this, when you do hit those times where you need to scale and you are ready to grow this solution, Chronosphere provides a perfect catalyst for that, and the perfect management system for that. Do you want to touch on that a little bit, how Chronosphere kind of helps with the scaling process of that?
Yeah, as as I talked about, the data store that we have is very highly scalable, right? And there's lots of other technical aspects of it that make it very reliable. Also, the control plane that we've built, which is, like I said, it's the very unique thing that is one of the unique things in this industry that a lot of observability platforms don't have. We built that because we knew of the issue that data was going to have, this amount of data that was going to be created. And so our founders, being from Uber, they spent, they saw this, they dealt with this. And so that's where we focused on giving people the tools to build out rules and things like that to allow them to shape their data, to transform it, to find the junk and get rid of that, and also to find the useful stuff and actually allow that to be, bubbled up higher and be ready, available to engineers to be able to use to troubleshoot.
Very cool. Awesome. Thank you. So I think we got one more question here. Okay. So probably again for Julius, but you mentioned Prometheus got a really cool history, really great story, right? Been able to do a lot of cool things with it. What's next for Prometheus, right? Like, are you aware of any kind of major changes or enhancements or things that you guys are working on that maybe isn't quite available, but that you might be able to kind of give us a little teaser about today?
Yep, there's some vague things and some very concrete things. Like one very cool technical thing that's happening right now is native histograms in Prometheus that are just being implemented now. And so histograms are a way, it's a type of metric in Prometheus that already kind of existed, where you can track the distribution of latencies of your service, or the distribution of request sizes, or some kind of numeric distribution in a histogram. But the current kind of legacy histograms, for those, you have to expose a single time series for each bucket of the histogram, multiplied with all other labels you have on those time series. So they can get very expensive while not giving the most amount of fidelity and detail and high resolution. So there's a big cost and resolution issue with those. And Björn Rabenstein and others from Grafana Labs and other companies, also Prometheus team members, they're currently implementing this kind of new native histogram that allows a full histogram to be stored in the sample value of a single series. So that will make that's one thing, but also the whole bucketing scheme is way more dynamic and fine-grained. So it will make histograms way cheaper and much better resolution. And it's already implemented in a kind of experimental way at the moment in the Prometheus server and in one or two client libraries, but it still needs to be made fully mature and propagated to all the other parts of the ecosystem. So that is I think really interesting for people who do have services where they want to monitor how fast they are. And yeah, on the other hand, like, we have so many small things that we're talking about on a day-to-day level where we're saying, we can't do this because it would require Prometheus 3.0. And so there's this very vague notion of a collection of issues and feature requests that, at some point when we do Prometheus 3.0, we might want to do that. And it's getting a little bit more concrete, but it's still very vague. So at some point, Prometheus 3.0 will probably happen. But we're still always obsessively trying to not make it happen, actually, because we were always, that means we would have to break millions of users around the world if we do that. So we're trying to just gradually integrate more and more features into the already stable 2.x version. So yeah, I mean, over the years, just so many new integrations and service discoveries and other things have been added. And yeah, I don't know if there's like another huge thing like the new histograms, but that's what I would like to say on that.
Yeah. No, that sounds great. Appreciate it. Okay, I don't see any more questions, so I appreciate those. And I just wanted to thank Julius and Scott for joining us here today. I really appreciate you guys sharing some really interesting stuff with us. It's very, very valuable. I think we all learned a lot. So appreciate you guys being here. And for everyone else watching with us, thanks for being here as well. Don't forget, we do have those 2 resources for you to explore and download and check out on your own time. And again, also feel free to reach out to Julius or Scott if you have any more questions about anything that was discussed here today. And then from DZone, don't forget to check out our website where we have a ton of other great events just like this one. You can go to dzone.com/events. We've got all of our stuff up there. You can see past events, our on-demand webinars. We've got a lot of great upcoming things. So be sure to check that out. We've got a lot of great variety of events, different styles of events that cover a whole range of topics. So there's definitely something for everyone there. Again, that's dzone.com/events. Be sure to check that out. That's going to do it for us. Once again, I can't say enough. Thank you guys so much for being here. Have a wonderful rest of your week, and we'll see you guys for the next one.
Thank you
very much. Thank you.
Thanks, guys. Bye-bye.